A rock from space crashed through a roof in Houston, bounced off a wall, and ricocheted around a bedroom like a pinball. The homeowner wasn't hurt. But here's what should concern you: that wasn't a freak accident. It was part of a pattern that scientists are only now beginning to understand. And the pattern is accelerating. Over the past several months, something has changed in Earth's cosmic neighborhood. And there's one region of space, a place astronomers call the Anthelion, that may hold the answer to what's happening. But we'll get to that. First, picture this: a Saturday afternoon in Texas. Clear skies, no warning. Then a 1-ton space rock explodes 30 miles above the city, unleashing a shockwave equivalent to 26 tons of TNT. Windows rattle, car alarms scream, and somewhere in a quiet neighborhood, a dark, jagged fragment punches through a residential roof. That wasn't a movie. That happened. And it was just one of dozens of similar events in recent months. Here's what makes this different from the shooting stars you saw as a kid. The American Meteor Society has been tracking fireballs, exceptionally bright meteors, since 2005. Their database is one of the most comprehensive records of what's hitting Earth's atmosphere. And when they analyzed the data from the first few months of this year, they found something disturbing. The total number of fireballs? About normal. But the number of large fireballs, the kind witnessed by 50 people or more, had roughly doubled. Events that normally attract a few dozen witnesses were suddenly being reported by 100, 200, sometimes over 3,000 people at once. Let that satisfying sink in for a moment. One fireball over Western Europe was so bright, so slow, and so spectacular that more than 3,200 people filed reports. It wasn't a streak across the sky. It was a 6-second descent, glowing and fragmenting, leaving a visible trail as it dropped toward the ground. When it finally broke apart, police in Germany reported damage to homes. This wasn't dust burning up in the atmosphere, this was rock. And the rocks keep coming. A week later, a 7-ton asteroid, roughly 6 feet across, screamed over Ohio and Pennsylvania. It moved so fast and burned so bright that NOAA's weather satellites picked up the flash from space. Their lightning detection system captured it. Not a thunderstorm, an asteroid. Witnesses across 4 states heard the sonic boom. Some felt their houses shake. That event alone told scientists something important. These aren't pebbles, these are boulders. And they're penetrating deeper into our atmosphere than usual. So where are they coming from? Remember the Anthelion, that region of space I mentioned earlier? Here's why it matters. The Anthelion is the patch of sky directly opposite the sun. Objects approaching from this direction are essentially catching up to Earth from behind as they fall deeper into the inner solar system. Think of it like a car merging onto a highway. If no one slows down, eventually you collide. Earth isn't slowing down, neither are these rocks. And right now, the Anthelion is twice as active as it should be. But here's the part that keeps astronomers up at night. 2 of the largest fireballs, the one over Germany and the one over Ohio, have something remarkable in common. Both dropped meteorites that were recovered and analyzed. Both turned out to be achondritic eucrites, a rare type of space rock forged over 4 billion years ago in the crust of a massive asteroid called Vesta. Same origin, same ancient parent body, but their trajectories were separated by nearly 100 degrees. They came from completely different parts of the sky, 9 days apart, yet they share the same cosmic fingerprint. That's not a coincidence, that's a signal. Here's what we know. This isn't a meteor shower. Meteor showers happen when Earth plows through the dusty trail of a known comet. The debris is predictable. It comes from a single point in the sky. What's happening now is different. The fireballs are coming from multiple directions. They're sporadic, unpredictable, and they're larger than the usual background noise of space debris. Scientists have ruled out a few explanations. It's not an undiscovered comet leaving a trail. It's not a new asteroid cluster entering Earth's path. And it's not just better reporting. Yes, more people have smartphones. Yes, AI assistants now direct witnesses to reporting sites. But that doesn't explain the sonic booms. A chatbot can't generate a shockwave. A viral video can't trigger a satellite's lightning detector. Something physical is different. The leading hypothesis: Earth may be passing through a denser than usual region of interplanetary debris. Small perturbations, gravitational nudges from Jupiter, collisions in the asteroid belt, resonance effects we don't fully understand, may have concentrated material along our orbital path. We're not in danger. These rocks are big enough to make noise, but not big enough to cause widespread damage. The largest events are still measured in tons, not megatons. But the question remains, is this temporary, or is this the new normal? Think about what happens when a fireball this size enters your neighborhood. There's no warning, no alert on your phone, no siren. One moment the sky is clear. The next, a shockwave rattles your windows and a fragment the size of your fist punches through your ceiling. The Houston homeowner wasn't in the bedroom when the meteorite struck, pure luck. If they had been lying in bed, the outcome could have been very different. And here's what's being done about it. NASA's Planetary Defense Coordination Office monitors near-Earth objects, but their focus is on the big threats, asteroids large enough to cause regional or global damage. The fireball-sized objects, the ones making headlines right now, are too small and too fast to track before they hit. By the time we see them, they're already burning up. The American Meteor Society is calling for expanded automated camera networks, systems that can independently calculate a rock's mass, speed, and orbit the moment it enters the atmosphere. Right now, much of our data comes from crowdsourced eyewitness reports. When the 7-ton asteroid exploded over Ohio, the only dedicated camera in the state was offline. We're flying partially blind, and the rocks keep coming. Remember that bedroom in Houston? The fragment that bounced off the walls and finally came to rest on the floor? It's now in a lab being analyzed. Scientists will study its composition, its age, its journey through the solar system. It's a piece of our cosmic neighborhood, delivered by gravity and chance to a suburban home. The universe doesn't care about our schedules. It doesn't wait for us to be ready. Every few days now, it sends a reminder. We share this solar system with ancient debris, wandering boulders, and forces we're only beginning to measure. So here's the question. If a rock from space crashed through your roof tonight, would you know what to do? Would anyone? The honest answer for most of us is no. And that might be the most unsettling part of all.